Proper nutrition is the foundation for good physical performance. It provides the fuel for the body. A continuous supply of food means a continuous supply of energy. It's important that you, the fitness professional, make yourself familiar with nutrients and the sources of food energy. In some of the previous chapters, we learned how the muscles contract and how energy is made, and these processes couldn't happen without an adequate supply of nutrition. Most people who engage in fitness training understand how muscles respond to exercise, but many have little knowledge of nutrition and how it relates to exercise. As a result, they often encounter problems because of inadequate, counterproductive, and even harmful nutritional practices. There's so many different opinions of what to eat, when to eat, how to eat, what to avoid, and what about combining foods. You may not always agree with some of the information presented in this manual because you may find that a certain diet works for you, or you've read conflicting information in a book or a magazine. A lot of weight trainers are convinced that supplements have somehow enhanced their performance or that protein powders have helped increase their muscle mass. In this manual, however, I'll try to provide you with as much scientifically based information as possible. I hope that this information and your continued learning after you finish this course will help you make educated choices about nutrition. It's important for us to make sure that we encourage people to eat whole foods and not pop a whole bunch of pills that may or may not actually work for the client. Here we'll talk about eating behaviors, food choices, nutrients, and how they affect physical activity. It's important to encourage people to do their own learning, but since we're not a registered dietitian, do not encourage our clients to go on strict diets or omit any food from any of the 4 food groups or take supplements to enhance performance. If you're asked to give nutritional advice, the safest thing to do is encourage the clients to look at the Canada Food Guide and ask them to see a registered dietitian. Look in your manual on page 162 and 163 about some of the general food guidelines. The Canada Food Guide is important to tell your clients about. The Canada Food Guide offers general advice on healthy eating. It's not intended to be followed strictly, especially by athletes whose caloric requirement goes up in relation to the amount of exercise they do. It doesn't mention the amount of sugar, salt, or cholesterol, but this simple guide is easy to follow and ensures a balanced diet with a standard intake of vitamins, minerals, and proteins. Its simplicity may encourage an otherwise poor eater to be more aware of the types of food that they eat. At the beginning of 2019, Canada's government came out with a new Canada Food Guide. And if you look at it, you can see that it's mostly fruit and vegetables on the left-hand side. In fact, half of your plate should consist of fruits and veg. The bottom right-hand side is made up of grains and pastas and breads and cereals. And you can see that it's about a quarter of what you should be eating. And then the top right-hand side is your protein. However, you'll notice that there's a lot of legumes, beans, and things like that. Very little meat. You can see this, they're showing it by just having a couple, 2 or 3 little chunks of meat. So the Meat Cutters Association wasn't very happy with this, nor was the Dairy Association. The old Canada Food Guide had a lot more meat and it had a dairy section as well. However, the new Canada Food Guide has no mention of dairy whatsoever, and you can understand why the dairy industry didn't take kindly to these changes. Here you can see that there's no mention of dairy whatsoever. It's mostly fruits and vegetables and grain products, most of the things that we grow. And there's no mention of milk, which made the dairy industry pretty unhappy. Even the beef industry weren't that impressed because there's a lot less beef in this as well. In fact, we should be eating less beef, more fruits and vegetables, and not drinking milk. We're the only species that actually drinks milk as adults. The new Canada Food Guide, because it's loaded with fruits and vegetables, doesn't actually give you serving sizes. It's pretty hard to overdose on carrots, strawberries, apples, and things like that. However, the old Canada Food Guide did have serving sizes, as you can see on the top left-hand side. In other words now, it's important to just eat lots of green leafy vegetables and colorful food like fruits and veg. You might also get this question on the BCRP exam asking you about other foods. The Canada Food Guide states that taste and enjoyment can also come from other foods and beverages that aren't part of the 4 food groups. Some of these foods are higher in fat or calories, so use these foods in moderation. Did you know that studies have shown that if people ate their full servings of fruits and vegetables per day, cancer rates could decrease as much as 20% and reduce the chances of heart disease and stroke? We know that there are many components in food: vitamins, minerals, and protein, fat, and carbohydrates. And these give you fuel, tissue growth and repair, and help regulate your metabolism. You may need to know this for the BCRP exam. It might ask you what the components of food are. We know that it's protein, fat, and carbohydrates that we discussed in Chapter 3, Physiology, and foods are also made up of vitamins, minerals, and water. I know we talked about a lot of energy in some of the key nutrients in the body are carbohydrates, protein and fat, vitamins and minerals, and of course water. Water isn't really considered a nutrient, but you couldn't live without it. And let's have a look in detail about some of these nutrients. First of all, we have carbohydrates. They include sugars, starches, and cellulose, which is a type of fiber. They provide the cells with energy, as you know, because you learned that in physiology, how important carbohydrates are in the forming of energy in your body. Did you know that carbohydrates are the sole energy source for your brain? That explains why you feel tired and grumpy and confused and perhaps even dizzy if you don't eat for a long period of time. And it's necessary for normal fat metabolism. You learned in Chapter 3 in Physiology how you need to have carbohydrates burning and then fat gets burned. That carbohydrates are made up of carbon, hydrogen, and oxygen. Hence, the abbreviation for carbohydrates is CHO. If you have a look on the bottom right-hand side, it shows you what a glucose or carbohydrate molecule looks like. It's 6 carbon, 12 hydrogen, and 6 oxygen. Carbohydrates don't make you fat, as some of those crazy diets out there tell you that they will, because they're only worth 4 calories per gram. They can't make you any fatter than protein does. 1% of the carbohydrates ends up in your body as body fat if you don't exercise it off. Did you know that you need about 55 to 65% of daily calories should be coming from carbohydrates? That's a lot more than people sometimes think, but if you look at the 4 food groups, which is fruits and vegetables, grains and cereals, that's mostly carbohydrates. And 1 gram of carbs equals 4 calories. It takes about 30 minutes to digest and absorb carbohydrates, so it might be a good pre-exercise choice. Excess carbohydrates can be stored in the body as fat. In fact, anything more than your body needs can be stored as fat. It's stored as glycogen in your liver and in your muscle, and glucose in the bloodstream. However, you can't store very many carbohydrates in the form of carbohydrates, glucose and glycogen in the body. A deficiency of carbohydrates causes the use of protein, and we'll get into this a little bit more later. Did you know that a low carbohydrate intake can cause fatigue and nausea? And that's because it's required for brain food. In fact, some people say that starches are bad for you, but starches are basically just a long glucose chain. And that means if you don't get enough carbohydrates, you can actually decrease the hormone serotonin. And serotonin is what makes you happy. So if you don't get enough starches, it can decrease the amount of serotonin, and it can cause irritability, moodiness, and fatigue. It's interesting to note that 70% of most cancers result from poor lifestyle. In fact, some studies have shown that the more fruits and vegetables people eat, the less chances of cancer that they have. Food components that confer health benefits within plant-based foods are called phytochemicals. And phytochemicals is derived, the word phyto is derived from the Greek word meaning plant. Thousands of chemicals that protect the plants from the harmful environment of the sun are in the food that we eat. Let's have a look at some of the different types of carbohydrates. There's starch, sugar, and fibers. There's something called resistant starch. Eating the right kind of starches can actually make you lose fat because starches aren't bad for you. People think that potatoes or bread are bad, but it's the things that you put on it, and eating an excessive amount of it is what's bad for you. Resistant starches can help reduce hunger. It's slower to break down in your body, so it can make you feel fuller longer. And they ferment in the large intestines, which causes you having less chances of bloating and having gas. And it also helps create beneficial fatty acids. These are going to help you function better, and they can prevent the liver from using the carbohydrate as a fuel. So this means fat is getting burned instead. It's not important to remember all the things that starches can do and where you get them from. Just suffice it to say they're good for you and we need to be eating more. Starches are known as complex carbohydrates, and here you can see a list of where you can get starches from. When people think of sugar, they think that it's bad, but there's naturally occurring sugars like the things that you get in fruit and milk. But then of course you can add sugar during processing. And this is like fruit canned in heavy syrup and some of the chocolate bars and other candies that people eat. There's something called simple sugar, and this is a fast-acting sugar. You'll sometimes see people going to the gym and drinking a Coca-Cola or something like that before they go. And this is because the sugar gets quickly into their system, giving them a lot more quick energy. The problem is, as the sugar goes in, it gets a high insulin response. And the insulin bundles up the sugar and takes it into the cell. But this can now actually cause a sugar low. It doesn't matter what you call sugar. Your body looks at it all the same way. Your body doesn't look at honey different than it does molasses or beet sugar or cane sugar. To the body, it's all sugar. Anytime you're reading a label and you see the words OS, fructose, lactose, dextrose, things like that, it basically just means sugar. So read the labels and don't get fooled when they start listing a whole bunch of different ingredients. Any diabetic will tell you how important it is to control their blood sugar. However, if you aren't a diabetic, it's still important to make sure that you're eating the correct carbohydrates throughout the day. That means eating carbohydrates with every meal, breakfast, lunch, and dinner, and whatever snacks that you have. And then we'll look at a different kind of carbohydrates called fiber, and fiber is found in plant foods. And this is usually the inedible fruit on the skin on the fruit, or they come in beans and grains and whole grains and things like this. It's the indigestible part of the plant. You may think, why do we need to eat anything that's indigestible? And this is because we help to maintain healthy bowels, as most of the fiber that's indigestible passes through you and basically keeps the bowels clean. Fiber helps absorb harmful chemicals in the body and can help prevent cancers. In fact, some studies have shown that people who don't eat enough fiber have higher incidences of colon cancer and even rectal cancer. Fibers can also help protect against heart disease because your body's working better and takes away some of the toxins. And some of the places to get fiber are grains and beans, and the peel and the stems of food, and even hummus. Animal products don't contain fiber. And it's important to eat carbohydrates throughout the day to prevent highs and lows of blood glucose levels. So eat a complex carbohydrates, and they're going to help you feel full. Another important nutrient is fat. Some people think that fat's bad for you, but it's important to eat fat in your diet, especially the good fat. It tastes good and it fills you up, and we need fat on our bodies for several things to keep you warm and help to protect your organs. The average person carries about 100,000 calories worth of fat on the body. And did you know this is your major fuel reserve? You need fat to make energy. Approximately 20 to 25% of your total calories should come from fat. You'll remember we talked about carbohydrates. It was 55 to 65% of your total calories should come from carbohydrates. 1 gram of fat yields 9 calories. You'll remember that carbohydrates was 4. And it takes about 4 hours to digest and absorb fat. And you may remember carbohydrates was about 30 minutes. Fat holds organs and nerves in place. and it helps protect you against injury. It's going to pad places like on your butt, and it's going to help pad your internal organs. And it tastes good and it fills you up. However, too much fat can cause obesity and heart disease. So, as with everything, there's variety and moderation. Compound fats are fat and protein together. These are called lipoproteins or fat proteins, and they help transport fat in the bloodstream. There's 3 categories of lipoproteins. The first one's called HDL, or high density lipid. And this particular lipoprotein has more protein than fat, making it very dense. So it rolls through the arteries, cleaning out the arteries and taking all the bad bits with it. And then we have what's called LDL, a low density lipid. And this has more fat and less protein. And this floats around in the system and can bang up into the side of an artery and start clogging it. And then there's VLDL, which has lots of fat and very little protein. And these are the ones that cause a lot of problems. So how do we get more or less? Well, it depends on the food that we eat is going to increase the bad lipoproteins, the LDL and VLDL. But how do you think we get more HDL? It's exercise. The more we exercise, the better your liver works. The more better your liver works, the more HDL we can make, and the less chances of heart disease we have. The LDL, the bad fat, carries cholesterols into the cells, and it can stick in the arteries, causing strokes and heart disease. Let's have a look at good versus bad cholesterol. Here you can see a schematic of the bad cholesterol, the LDL, and you can see how it sticks to the side of the arteries, where the good cholesterol, represented by the little green circle, goes through and starts picking up the bad fat. Did you know that your liver produces cholesterol every single day? It's a waxy type substance, type of fat, and we need it in our bodies because it's present in every single cell in the body. Cholesterol is going to help your skin produce vitamin C and keep it healthy. And it can insulate nerve tissues and maintain cell membranes. And it can help develop adrenal and sex hormones. So we need to have cholesterol in our body. The problem is when we get the wrong kind and we get too much. Cholesterol is absorbed into the blood and then into the liver. The liver, which is the largest organ other than the skin, wraps protein around the cholesterol. A healthy liver and the right amount of food and exercise is going to make the good cholesterol. If the liver is unhealthy, then it's not going to know what to do with it, and it creates more LDL, the bad cholesterol. So, exercise increases the HDL, and it removes the bad cholesterol from the bloodstream. So it's simple to tell people how to reduce their cholesterol levels is by exercising more. Let's have a look now at some of the bad fats. The bad fats are called saturated or hydrogenated fat, and these are usually hardened at room temperature. They contain a lot of cholesterol, and they can cause hardening of the arteries. The hydrogenated one can be liquid vegetable oil that's been saturated with hydrogen atoms, and this increases the LDL in the body, and there's lots of the hydrogenated fat in the fast foods that you eat. Bad fats come in all kinds of forms, but they come in fast foods and fried foods. And if you ever go into a grocery store and see the cookies and the pastries and the donuts that aren't in a refrigerator, the reason that they can put them out of a refrigerator is because the fats help solidify them so they don't go as bad as quickly. So avoid these. Generally, if something leaves a coating on your tongue, then you probably know it's the bad fat or hydrogenated fat. The good fat is called unsaturated fat. It's monounsaturated and polyunsaturated. And the good fat can prevent heart disease, it can lower the bad fat, the LDL, and it can prevent certain cancers. Olive oil can help protect against breast cancers. And polyunsaturated are the omega-3s. You may have heard of omega-3, 6s, or 9s. And these can aid in heart health and fight things like breast cancer. Eating fish is going to help prevent against certain cancers. It can increase the HDL, and it can make you feel a whole lot better because it's a good kind of fat. Just don't boil the fish. You may have gone out and bought yourself some fish oil, but basically what the supplement companies do is squeeze the oil out of the fish and then they package it up and sell it to you and you pay 10 times as much. However, when the fish oil is packaged, it loses its punch. You'd be better off just to go and buy and eat the fish. Omega-3s that come from fish help reduce blood pressure, heart disease, cholesterol, and some cancers. So the moral of the story is, eat more fish. The good fats are usually vegetable related. They have a low melting point, and they're found in soybean and sunflower, corn oil, flaxseed, and cold water fish. And then protein, which is the other macronutrient. And this is a large chain of amino acids, and they're the building blocks of every single thing in your body. So we know that there's about 12 to 20% of your daily calories should come from protein. You'll remember that carbohydrates was 55 to 65% and fat was 25% or under. 1 gram of protein equals 4 calories, and it takes about 2 hours to digest and absorb. So if you are going to go work out, don't eat a lot of protein before you go and do that, at least not for a couple hours. You know that protein builds and repairs tissues like muscle, hair, skin, gums, antibodies, cell walls. So anything that grows is made out of protein, which means that you can make more, make it bigger, or make it stronger. And did you know that you burn twice as many calories digesting protein as you do carbohydrates? However, too much protein is not a good thing. Too much protein is turned to fat in your body, which can make you fat. It can cause heart disease, certain cancers, even osteoporosis as calcium is drawn from the bones, and it can create kidney damage. Other nutrients in your body are called minerals, and these are the structures that help form the bones and the teeth. They regulate cell activity, they maintain normal heart rhythm, they help regulate the pH in the base of the body, and they give what's called neural conductivity, helping your nerves work properly. And vitamins help regulate metabolic reactions and tissue synthesis, which means that they help the body make more tissue. And they also help release the energy in food. Vitamins and minerals are not directly related with the amount of ATP production that you have. That's because carbohydrates, fat, and protein take care of that. But without the right amount of vitamins and minerals, you wouldn't be able to do that efficiently. Let's learn to read labels. Labels, however, may mislead you as they don't give you all the facts. If you look here, the label is going to tell you exactly what nutrients are in this one serving of this food. It should help you make healthy choices, and it should also tell you which foods to stay away from. So this is your typical label here, and you can see the large black line. This first part is telling you what the serving size is, and it's going to give you a half a cup. And then it's going to tell you how many servings there are per container. So we know that there's about 2 cups of food in this particular food item. And then this next bit is going to tell you what the amount of calories are. And it's going to tell you that there are 90 calories in that half a cup. So if you were to eat 4 times as much, you know that you would be eating 4 times as many calories. And then here it's going to tell you the percent of daily value, and this is based on a 2,000 calorie a day diet. And you may be needing more or less, so this doesn't really hold true for everybody. And then it's going to start discussing this. We'll talk about doing the calculations for this in just a moment. Here you can see that it tells you the fat percentage of the total intake. So it's going to tell you in the fat that's in this food, you have 5% of what you need. However, if you're eating 4 times as much, remember we talked about this, not just eating half a cup, you're eating 2 cups. It says you're getting 5% of the fat you need, and now you multiply that by 4. It's telling you that in this one food item, if you've eaten 2 cups, you're actually going to be eating 20% of the total amount of food that you should be eating for the day. And then here it talks about salt. And we know that table salt is used to help preserve food. So it said that you should eat less than 2,400 milligrams a day. And here already it says 300 milligrams. So you can see this is pretty salty. If you're eating 4 times as much, 3 times 4 is 12, you're already getting half of what you should as far as salt goes in your day. And then it talks about carbohydrates and protein, just as we talked about fat. Here it says you're getting 4% of what you need throughout the day, but you've eaten 4 times as much. So we know that that's 16% of what you need for carbohydrates. And underneath this line is what the companies want to give you. This is everything they have to give you, and underneath this line is what they want to give you. And you can see here they're telling you about the vitamin and calcium and iron that there's in your food. And this is to make their food look better. However, you can see this is only 4% of iron, and even if you ate 4 times as much, you're not getting very much iron out of this food, so you're going to need to eat other foods to get the right amount of minerals. So let's have a look at how we calculate. You know that if there's 3 grams of fat, we're going to multiply that by 9 because there's 9 calories per gram of fat. So 3 times 9 is 27. And then you're going to divide that by the total number of calories in the food. So this is telling you that there's actually 30% fat in this food. You'll remember this is right here. This is what you need during the day. This is your daily value. But this is telling you what the percentage is in the food that you're about to eat. So let's have a look in further detail how to calculate fat in food. So it's important to read labels, and any food with more than 30% fat should be avoided. Don't be fooled though if the label says 20% fat, they mean 20% of your daily limit. They're not telling you the percentage of fat in the actual foods. Okay, so we're going to learn how to read a label. If you read the back of a label of a can of soup or a bag of chips, it's going to tell you what the protein, the carbohydrates, and the fats are. And you'll remember that proteins are worth 4 calories per gram, carbohydrates are worth 4 calories per gram, and fats are worth 9 calories per gram. So let's have a look at a can of soup. It tells you what the total weight is, both in ounces and milliliters. And here we've got 250 milliliters per serving. We're not going to be too concerned about that right now, but what we do care about is the total number of calories in that serving. Let's say it's half a cup. It's going to tell you in that half a cup is 94 calories, and it's going to tell you that there's 2.7 grams of protein, 0.4 grams of fat, and 20 grams of carbohydrates. So we need to figure out what the total amount and percentage is that comes from protein. We've already determined that 2.7 grams of protein is in this serving. So we're going to take 2.7 grams and multiply it by 4. And the reason that we do that is because you'll remember that protein is worth 4 calories per gram. So 2.7 grams of protein times 4, and this gives you 10.8 calories. Then what we need to do is take that amount of calories, and to get a percentage, you'll remember from high school that we divide it by the total amount that's in there. So 10.8 divided by 94, and it's telling you that this food is 11% protein. The next step is what is the total amount and percentage that comes from fat? So we take the label, it says 0.4 grams, and we multiply that by 9 because there's 9 calories per gram in fat. Once again, 0.4 times 9 is 3.6 calories. 3.6 divided by that total number is 3%. So we can see that in this can of soup is only 3% fat. Now let's take a look at the carbohydrates. The label told you there was 20 grams of carbohydrates, and we know that carbohydrates are worth 4 calories per gram. Pretty simple math. 20 grams times 4 equals 80 calories in that half a cup serving. We're going to take 80 and divide it by the total number of calories, gives you 85%. So how do we check our answers? If you add up all of these, they should come out to more or less 100%. If it's way under or way over, you've done something wrong with the calculation. You know how important water is. Did you know that the average body is made up of 52% water? In fact, water makes up 65 to 75% of the muscle's weight. So stop weighing yourself. The more muscle you have, the more water you have in your body, and the more you're going to weigh. Water is taken in its own right or is produced metabolically from protein, carbohydrates, and fat being broken down. Let's have a look at what can happen during dehydration. Did you know that your thirst mechanism isn't in sync with your dehydration mechanism? When you become dehydrated, it's inside of the cell to start off with, and then it starts getting dehydrated outside of the cell, and then in the veins and the arteries. However, if you start feeling thirsty, it's when you're already getting dehydrated in the veins of arteries. As I said, your thirst mechanism isn't in sync with your dehydration. You can be up to 10% dehydrated if you're becoming thirsty. Up to 2 pounds of water can be lost during exercise. This can cause a 15 to 20% loss of efficiency. We know that water carries nutrients and oxygen and wastes away. It can aid in digestion and absorption. It helps lubricate joints. It'll help maintain body temperature, and sweat carries away with it heat. So it'll help us prevent from overheating. Dehydration is caused by overexertion and perspiration, and of course, a low water intake. It can cause anything from lightheadedness to extreme fatigue or even death. We know we lose water through urine and perspiration and breathing. Did you know that 75% of us walk around chronically dehydrated? And this is because the thirst mechanism isn't in sync with the water content. And a lot of people reach for sodas and things like that when they're thirsty. And thirst can actually be mistaken for hunger. 1% dehydration can impair physiological function. It can impair performance. It can slow the metabolism up to 5%. And dehydration is the #1 reason for daytime fatigue and headaches. 2% dehydration can make you have a fuzzy short-term memory. It can give you difficulty reading, inability to do simple math, and it can also cause muscle cramps. 5% dehydration can cause extreme fatigue, nausea, lightheadedness, and if you're dehydrated for long periods of time, it can increase your chances of colon cancer, breast cancer, and bladder cancer. 20% dehydration can cause heat exhaustion, which can cause heat stroke, and that can cause death. Not everybody likes drinking water, but it's important to make sure that you get some kind of fluids into you. So there are some studies shown that say sports drinks can help you if you don't drink enough water. However, some of these sports drinks are higher in calories and higher in salts, and some of them will tell you that you're going to help replace the electrolytes and glucose, which means they have salt and sugar in them. Only people who are working out more than 90 minutes to 2 hours a day actually need to start replacing their electrolytes, because you get enough from the food that you eat, and also enough, your body produces enough. The body can replace electrolytes naturally. So drink whatever you can to help you replace the water that you've lost during exercise and normal daily functions. Did you know it's almost impossible to be overhydrated? Because if you have more water in your body than your body needs, you basically pee it out. There are, as with anything, exceptions. Drinking too much water can cause sodium levels to drop because your body's going to flush out water and take with it salt. And there's a psychological disorder, which is an obsessive compulsive disorder called psychogenic polydipsia, which causes someone to drink lots and lots and lots of water. So how much water do you need? If you're going to go and exercise, you need to have about 2 to 3 cups of water about 2 hours before. 15 minutes before, another couple of cups of water. And every 15 minutes while you're exercising, another cup of water. That's about 2 to 3 good mouthfuls. After exercise, you need to drink enough water until the urine is pale. Urine should be colorless and odorless, and it's not okay to substitute colas, teas, coffees, and other beverages like that, as some of them are actually diuretics, which means that they make you urinate more. Your intestines need about a cup of water a day. You breathe out about 1.5 cups of water a day. Your lungs and other respiratory organs need about 2 cups a day just to survive. Your skin needs about 2 cups of water. Your kidneys need 5.5 cups of water, and this is 12 cups of water a day just to stay alive. Now, if you start adding exercise to that, or you're in a hot environment, or you drink alcohol that can be diuretics, you can see how you're going to need more water than that. It's important to sweat. As we learned about before, sweat carries away heat and toxins from the body, but if you're not replacing it after exercise, it can cause dehydration. Did you know you can lose up to 2 pounds of water from just exercising? Let's now talk about some of the supplements. Are supplements totally necessary? If you're eating the right amount of food, no, they're not. And it depends on where you get your food as well. Organically grown food actually has more vitamins and minerals in it because it's grown properly in the first place. And it's how we process our foods as well. Having said that, if you have too many supplements, they can actually become toxic in the body. And they can build up, and it can take years and years, up to 10 years to build up in the body before they become toxic. We have fat-soluble vitamins, which are A, D, E, and K vitamins. And these are the ones that are actually stored in the fat cells. And so yes, they can accumulate as well. However, we can also get excessive water-soluble vitamins, which are the B and the C vitamins. While you can't accumulate them and store them in the body, they can cause a host of other problems if you're having too many of them. Hippocrates said, "Let food be thy medicine." And let the supermarket be nature's pharmacy. Shop at the outer aisles, pick food from the 4 food groups, and pick as natural foods as you can. Some people megadose on vitamins or minerals, and this can be very hard on the kidneys as the body tries to get rid of the excess vitamins or minerals. Megadosing on one vitamin or mineral can throw the other out of whack. For example, zinc and copper function very closely together. So if you all of a sudden decided that you need more zinc, it's going to start reading copper as a deficiency. And this is going to tell you that there's an imbalance. And you'll have heard of creatine. Creatine is what helps you make energy. You'll remember the ATP-CP system. That's adenosine triphosphate and creatine phosphate. So creatine's job is to bind with a protein to help give you that immediate energy if you got up and ran out the door. Some studies have shown that creatine can benefit Olympic athletes or elite athletes, and these are people that can run out of ATP-CP because they're exercising so much. But for the average person, there might only be a 1 to 2% boost in energy. Did you know the kind of exercise that you do and how well you do it doesn't depend on mineral and vitamin supplements and other things that you take in pill form? Your exercise performance depends on what you've eaten, when you've eaten, how much sleep you got, and your desire to train. Creatine is made naturally in the liver, the kidney, and the pancreas from the amino acids or the proteins that you eat, and it's stored in the muscle. Some of the claims of creatine is that it improves high-power performance, it promotes quick and greater muscle gains, and it helps delay the onset of fatigue. Well, it may improve the high-power performance if it works for you, because you'll remember again, it's the ATP-CP system, which is your immediate energy system. However, it can't make you gain muscle more. Overloading and hard work and eating right and resting does that. Here's some creatine facts. 4 to 5 grams, 3 to 4 times per day for 3 to 5 days may improve brief maximum output, which means that you may get more out of your exercise in the first 10 to 20 seconds. However, if you're drinking caffeine, you might as well not bother taking the creatine. And we know that the exercise type is also going to be dependent on the fiber types. So people with more fast twitch muscle fibers are going to benefit from it more than people who are more aerobic animals and long distance runners. Creatine isn't for everybody. Your body's going to make it naturally. Here's some of the side effects of creatine. If it doesn't work for you in a week, it's probably not going to. Did you know that the people who it works best for are post-menopausal vegetarian women? And there is concern as well about dehydration in the muscle cell if you're taking too much creatine. And it can cause cramps and strains. It can cause kidney stress and liver damage. And there's no long-term studies done. However, a study in France showed that if you take too much creatine, it can actually cause cancer. And again, here are some of the side effects: muscle cramping, increased urination, nausea, and diarrhea. Let's now look at protein supplements. Physiologically, the body is able to build muscle tissue at a certain rate, and this is going to be dependent on genetics, the food you eat, how much you eat, when you eat, how much sleep you got, and the type of exercise you do. Research reports that even huge men can gain only about 25 pounds of lean tissue a year. And marketing, of course, works. It hits you in the heart. If someone promises you a quick fix, you might just want to take that magic pill. Muscle growth is strictly controlled by genetic makeup and the type of exercise you do. Additional protein, more than your body needs, is converted to glucose, and that glucose is then converted to fat. When you're training, your clients may ask what kind of food that they should be eating. Instead of supplementing, tell them to eat real food and tell them to follow the Canada Food Guide. If they need more information than that, refer them to a dietitian. After any type of activity, it's important to consume foods high in carbohydrates and plenty of fluid. This helps you replace the nutrients lost during exercise. And it's the combination of both carbohydrates and protein that will help the absorption of the other. It can take 24 or more hours after you exercise to fully replace the glycogen that you lost during exercise. Not eating carbohydrates right away after exercise actually slows the glycogen synthesis and inhibits recovery. When you start thinking about ingesting glucose before a competition, think about the kind of carbohydrates you're eating. Pop and chocolate and sweets give you a big rush of sugar, and this simple sugar enters the bloodstream. And then insulin is released because the insulin is going to bundle up that sugar and take it into the muscles. Then you'll get what's called a fall in blood glucose, and this can cause fatigue, dizziness, and nausea. So if you want a quick fix, eat properly. Don't start relying on things like pop and candy to help get you through the workout. We know that we should be eating complex carbohydrates as it fuels the cells, and carbohydrates only stays in the stomach for about 30 minutes. We want to eat things like pastas and fruits and vegetables to help us get through the workout. We're not going to get into a lot of information about eating disorders, but it is important for you, the trainer, to learn how to recognize it. It's important to understand what people are going through and not judge them, as it is a type of a disorder. So if you do suspect someone has an eating disorder, it's important to talk to them openly and refer them to a doctor. At this point in your career, you're not going to be qualified to deal with eating disorders. As I said before, if you suspect someone has an eating disorder like anorexia or bulimia, have a conversation with them. Don't confront them, but see what they have to say. People who are anorexic or bulimic will often be far too thin and exercise far too much. Again, this is something that you should hand off to your supervisor and let them deal with it. Here we'll talk about osteoporosis. Osteoporosis is because you get less calcium in the bones and the bones start to break down. You may remember from chapter 4 when we were talking about osteoblasts and osteoclasts. Remember that every single day your bones are getting broken down, and with the right amounts of minerals and nutrients, they get built up again to make them stronger. Calcium is the most abundant mineral in the body that helps form the bones and the teeth. And without calcium, our muscles couldn't contract. Calcium is going to help transmit nerve impulses, activate certain enzymes, aids in blood clotting, and helps transport fluids across cell walls. There are several places that you'll get osteoporosis as you age if you don't take care of yourself. At the distal radius and ulna, that's by your wrist, in the lumbar vertebrae, your lower back, and in the hips. Very common places to have bone breakage. We know that if you weight bear and you do any kind of strength exercises, it's going to cause you to have stronger muscles. The muscles then pull on the periosteum, which is the coating to the bone, and that periosteum is going to pull on the bone to make the bone stronger. Of course, the building of bones is going to be dependent on the type of exercise that you do and making sure that you get adequate amounts of nutrients, especially calcium, in your system. Let's have a look at the difference between a healthy bone on the left and the osteoporotic bone on the right. A healthy bone, you can see, has the solid bone on the outside, called compact bone, and then it has the spongy bone and the marrow on the inside. And you can see that this is going to give its rigidity here with the compact bone and the flexibility with the spongy bone. However, the more brittle the bones become, the more osteoporotic they come. Because if your bones have nothing to build up with, you don't get enough calcium, they're going to become very porous, hence the name osteoporosis. So where do we get calcium from? Obviously milk, but some people don't like to drink a lot of milk. So you can get it from yogurt or other things like that. Green leafy vegetables, tofu, and some fortified cereals, although most of the calcium that you get in your system are from dairy products. And now we'll have a look at anemia. And this is very common, especially in runners. People think that because they weight train, they need to have more protein than someone else. The fact is that runners need to have more protein, and the reason for this is protein combines with iron to make hemoglobin. And you'll remember that hemoglobin is your iron-containing protein in the bloodstream that helps carry oxygen. So anemia is an iron deficiency. Hemoglobin is responsible for storing and delivering oxygen to the cells, and if you have low iron, you'll have low hemoglobin, which means you'll have low oxygen levels in the body, and then you'll get fatigue. Iron comes in two forms. There's non-heme iron and heme iron. And non-heme is from plant products, and you only absorb about 2 to 10% of the iron that's in that plant, whereas heme comes from meat products, animal products, and you can absorb up to 35% in that. And if you drink coffee with your meal, it can actually prevent you from absorbing the iron. However, if you drink vitamin C, like a glass of wine or some orange juice, or have high vitamin C foods, it'll increase the absorption. So think about this. If you have a steak and a cup of coffee, you won't absorb as much iron than if you had a steak with vitamin C. And runners are susceptible to a deficiency in iron, and this is because the pounding of the running actually ruptures red blood cells. And as I said before, runners need more protein than a bodybuilder. In North America, we're so lucky because we have an abundant supply of food, which should mean that we're getting adequate nutrition. But it's not uncommon for people to have poor nutrition in our country. Many people are unaware how to eat properly. And there's an obsession with fast food, and a lot of the fast food restaurants don't really think about having good nutrition, they just think about filling you up. With the abundant food choices that we have, we should have better nutrition, but what's happened is we've become an overweight country. Now carry on to the next chapter, chapter 10, which is diet and exercise. These two chapters go hand in hand, of course, because they're nutrition, diet, and exercise. The assignment for this chapter, chapter 9, is together with the next chapter.